Today we're going to talk about how blood flows through the heart. And with the steps written on the side there, I'm going to go through this pretty quickly, so it's not a long video. A few things we need to know up at the front is that when we talk about our diagrams are often drawn in red and blue. And that has given people the misconception that our blood can be red and our blood can be blue. And that is a misconception. That is incorrect. Our blood is red. It is always red. The blue simply represents deoxygenated blood in the flow of our bloodstream. And so that's what the blue is. It's deoxygenated. Our blood is not actually blue. Some people say, well, the veins, they are. Look at my veins, they're blue. That's because the vein walls are thicker, and so with the blood running through them and the way that the light hits it, it causes the light to bend and twist, and it looks like it's blue, but your blood is red. Proof for this is when you go to the doctor and you need to get a blood draw, they draw the blood into vacuum-sealed tubes, meaning that there's no oxygen in those tubes because our blood does react with oxygen. And so when they put the needle in your vein, in those blue things in your arm, and they draw the blood out, your blood does not come out as blue, it comes out as red. And so in our diagrams and in my notes, red is going to represent oxygen-rich blood, and blue is going to represent oxygen-poor blood. Oxygen-poor blood has CO2 in it. And this is important because, as we're going to discuss later, this is part of the process of the gas exchange, of the CO2 being removed from our body and exhaled, while the oxygen that's inhaled is taken into our body and delivered. So with this, when we start, we're going to start with our deoxygenated blood. So it's going to come from the body. It's going to enter the inferior vena cava and the superior vena cava. Superior just means top, inferior just means bottom. So it's going to enter the vena cava. When we go towards the heart, those are our veins. So the designation of veins versus arteries, veins go towards the heart. Arteries go away from the heart. So it's going to go towards the heart into the vena cava. From there, the blood will enter the right atrium. After it enters the right atrium, it's going to go through this tricuspid valve. The valves are like flappy parts of like skin flaps, or like you can imagine maybe like the spring doors that you push open and they kind of slam shut. Some bathrooms have those, but our first valve is our tricuspid valve. So the blood is going to go from the right atrium through the tricuspid valve into the right ventricle. The atria are the chambers that are up top. They're very thin, they're not very muscular. And that's because they're pushing the blood from the atria to the ventricle. So there's not really much distance for it to go, so we don't need a lot of pressure. Then the blood is going to go from the right ventricle to the pulmonary artery through the pulmonary valve. So our pulmonary valve is right there. The right ventricle, the blood will empty from the right ventricle through the pulmonary valve into the pulmonary artery. Artery means away, so the artery is going to move away from the heart. And it will go towards the lungs. Once it goes to the lungs, we're going to do this gas exchange. And so at this point, since we came from the body, we were oxygen-poor blood. Well, now we're entering the lungs. So the CO2 is going to be swapped for the O2, and now we're going to have oxygen-rich blood. And so the oxygen-rich blood will exit the lungs and will enter the pulmonary veins. We're going towards the heart, so they're veins. Once it goes into the pulmonary veins, they kind of meet back here as a branch. And so once it does that, then it will come in through the left atria, and we have another valve. We have the mitral valve. So it'll enter through the pulmonary veins through the mitral valve into the left ventricle. So again, the left atria transfers blood to the left ventricle. So again, the atria aren't working against much else, and so the pressure is low. The muscular walls are very thin. It doesn't need a large amount of muscle. After it goes through the mitral valve from the left atrium through the mitral valve to the left ventricle, it's now going to go through our aortic valve. Our aortic valve, which is right here, aortic valve, is going to go through the aortic valve and through the aorta. The aorta has 3 branches, and those 3 branches are to take the blood to the various parts of the body. Now keep in mind that my diagram is simplified, and so it's drawn as coming in one side of the body and going out the other side. That's not the case. It's just for simplicity's sake. So again, my blood will exit the left ventricle through the aortic valve, will then leave the aorta and go to the body. When it goes to the body, it's going to do another gas exchange, where this time the gas will be exchanged. The oxygen will be dropped off to the parts of the body, and CO2 will be picked up to be exhaled. After that, our deoxygenated blood goes back to the inferior vena cava and the superior vena cava, and the whole process starts again. The really amazing thing about this is that it takes about 20 seconds for the blood to complete this cycle. So starting from step 1 all the way through step 13 takes about 20 seconds for your blood to get all the way around your body. It's pretty crazy. Something else to mention is that, as I said, with the ventricles are going to be much larger than the atria, because the atria are just emptying into the ventricles. There's not a lot of pressure. It's not very far for it to go, so the atria don't need to be big and bulky. When we see these on our dissection, these are going to look kind of like skin flaps that are on top of the heart. The big muscular part of the heart that you typically think of when you think of a heart is actually the ventricles. So this part here that you usually think of as the heart is the ventricles. The atria kind of sit on top of the heart, on the outside of the heart, and so I'll point that out to you when we do the dissection. The other thing that I wanted to point out to you is that, again, like I said, because the ventricles are pushing away from the heart, here the ventricles are pushing to the lungs. Well, the lungs are very close to the heart. And so it needs more pressure, but it doesn't need too much. And so because of that, our right ventricular walls are not very thick. They're pretty thin. They're still thick. You still need pressure to push it, but they're not nearly as thick as our left ventricular walls. And that's because the left ventricle is responsible for pushing the blood through the aortic valve to the body. And so it has to get to your head, to your tippy toes, to the edge of your fingers. And so our left ventricle has a much thicker muscular wall than the right ventricle because it has to push it further. Again, 20 seconds to get all the way through our body versus the 20 seconds that you have to get to the lungs. And so if you were starting from the lungs and going. So it's a much stronger, much thicker muscle. The last thing that goes into this is our blood pressure. When you go to the doctors and you get your blood pressure, it'll usually be given to you in some format of like this. This is a very healthy adult blood pressure, 120/70. What the 120 means is the 120 is the systolic pressure. And the systolic is measuring the pressure needed by the ventricles to push the blood to the lungs and to the body. And so as we said, since it's going a far distance to the lungs and to the body, making it around the body in 20 seconds, it requires more pressure. It's also because if you notice, in most cases, maybe not when you're laying down or if you're doing somersaults or something, but the ventricles push the blood up. So it's also going against gravity. That's less of a case. It is going against gravity, but it's also going a very far distance. So this is our ventricular pressure. known as our systolic. The diastolic then, the diastolic is the smaller number on bottom, and the diastolic pressure is the pressure required for the atria to move the blood into the ventricle. And so it's not a long distance for this to happen, it's just emptying into it, and it's going with gravity. And so because of that, we don't need a strong muscle, we don't need a lot of pressure. And so that's why our number is lower. This is how blood travels through our bodies and how you read a blood pressure. The last thing that I need to mention is when you hear a heartbeat, it makes a stereotypical lub-dub sound. The lub is your diastolic. The lub is your atria pushing that blood into the ventricle. The dub, which is a much more intense beat, is your systolic pressure. It's your ventricles pushing the blood to the body. So the lub-dub. The lub is the atria exiting or emptying. The dub is the ventricles pushing it to the body. When you feel your pulse, you're feeling the dub part of that. You're feeling the ventricles as they're clenching and pushing that blood through the body.